Okay, our next section that we're going to talk about is 14.2, where we're actually going to get into applications of finding extrema, maximums and minimums. So we talked in the last section about how to find absolute maximums or absolute minimums, but now let's apply it to some kind of real world problems. Because some of the most important applications we use calculus for are optimization problems, where we're actually trying to find the best way of doing something. Maybe you want to maximize your profit and you don't want just a relative maximum, you want the absolute maximum profit. Or maybe you want to minimize your cost, something like that. And so this can be done by using the same techniques that we did in the last section of finding the absolute maximum and minimum. A little bit more challenging because they're going to be word problems. So here are some steps that you can follow as you're doing word problems. You can kind of read over those. But this is kind of how I've set up each of my examples. We want to first figure out what we're trying to minimize or maximize and come up with some sort of an equation that we can use. Because, remember from last section, if we're trying to find the absolute minimum or maximum, we want to find its derivative, we want to find its critical numbers, we want to take those critical numbers and plug them into our original, and we want to find some endpoints and test all of those to see which one's going to give us our absolute maximum or our absolute minimum. So we need to first figure out what we're trying to optimize, find the maximum or minimum of. Sometimes though, we might be trying to optimize an equation that has multiple variables, x's, y's, maybe lengths and widths, something like that. And we don't know how to find derivatives right now where we have multiple variables. So we might need to use a secondary equation to help us solve for one of the variables. Using those two combined, we might have to come up with some sort of a new equation that just has one variable in it so that we can then find the derivative with respect to that one variable instead of a whole bunch of different variables. We would then need to figure out what the domain is. Are there any restrictions? How low can we go? How high can we go? Kind of like endpoints. What is our lowest value? What is our highest value? So that we have some kind of domain restrictions there, endpoints to use. We're then going to take those critical numbers that we found. We're going to take our endpoints that we found before. And remember, we're going to check those in our original. Whatever we're trying to maximize or minimize, we want to plug it into that equation to see which one's going to give us our highest and lowest values. So that's kind of how I'm going to set up and organize myself for each of these examples. Let's do example number 1. It says here, find two non-negative numbers, x and y, for which 2x plus y equals 30, such that x times y squared is maximized. Okay, so the first thing we want to do, remember, is figure out what we're actually trying to find the minimum or maximum of. And it says in the problem, if you read it again, that we're trying to find the maximum value of this equation, x times y squared. So that's how I'm going to start. I'm going to find the thing that I'm trying to find the minimum or maximum of. And so I know that I'm trying to find the maximum of that x times y squared equation. So I put that over here. The problem is, if I'm trying to find the minimum or maximum of this equation, typically we would want to find the derivative, the critical numbers, and test them, right? But I don't know about you, I see way too many variables in that equation. I see an m, I see an x, and I see a y. And so there's way too many different changing pieces that we don't know how to find the derivative of yet. So somehow we need to manipulate that equation and turn all of the x's into y's or all of the y's into x's. This is going to be done by finding a secondary equation. Was there anything else in the problem that they told us about x's and y's? Yeah, well, didn't they tell us that 2x plus y has to equal 30? So I'm actually going to use that equation, the 2x plus y equals 30, so that I can solve it for one of the variables. I need you to either get it to say x equals or y equals. And it does not matter which one you choose, we'll all get the same answer in the end, but I solved it for y. I got it to say y equals 30 minus 2x by subtracting the 2 over. What that helps me do is that helps me take the problem, the equation that I'm actually interested in, and instead of calling them x's and y's, well, everywhere I see a y, I can plug in this 30 minus 2x. So I'm going to go down and I'm going to make myself a new equation that just has one variable in it. And so now I want the equation that I want to try to maximize of the x times y squared, but instead of calling it y, I'm going to call it this 30 minus 2x. If you notice now in my new equation, this is what I'm trying to find the maximum of, And now look how many different variables I have, right? I only have the m and the x. And so then I can find the derivative, the rate at which this is all changing with respect to x, because there's only x's in my equation. Before I find the derivative, I suggest you FOIL this out, distribute, and combine like terms. So pause the video and do that for me and see if you get the same answer as me. Oops. I FOILed out, I distributed my x, and so this is the equation that I'm trying to find the maximum of. This is really the x times y squared. It just looks a little bit nicer because there's all x's in it. But really, this is the important equation that I'm trying to find the absolute minimum or absolute maximum of. In this particular case, we want to find the absolute maximum, right? And so like we did yesterday, or in 14.1, we want to find the absolute maximum by following the 3 steps. We want to find the derivative, we want to find its critical numbers, we want to test those critical numbers and endpoints in our equation to figure out which one is going to give us our maximum value. So find the derivative of this equation. And then let's find his critical numbers. Remember, critical numbers are when the derivative equals 0 or doesn't exist. So set that derivative equal to 0. I rearranged it. Probably factor, hopefully 12 comes out of all of those. So factor out, pause the video, and see if you get the same answer as I do. I factored out a GCF of a 12, and then I basic factored. I set each piece equal to 0, and I ended up getting 2 critical numbers, x equals 15 and x equals 5, right? So far, these are my 2 critical numbers that I can use to figure out which one of those is going to give me the best value. But remember, who could maybe possibly be higher or lower than my critical numbers? My endpoints, right? So really what we should be doing is going back to this domain piece and figuring out what numbers can be my very lowest x and what number could be my very highest x, right? Because that's what I solve for is x down here. And so I need to figure out what's my very lowest and what's my very highest x value. Now, they're not going to say it in the problem necessarily. So this is kind of going to be the difficult part where you have to kind of critically think about what x could possibly be. What's the very lowest x could possibly be in this scenario? Well, one of the key parameters that it put for us is that x and y both have to be non-negative, right? And so at the most, x could be 0 or anything bigger than that. So can I say x has to be greater than or equal to 0? And so 0 is probably the lowest x could be, but what's the highest x could be? Well, let's think about y real quick. If y has to be non-negative, that means he has to be greater than or equal to 0. Well, wasn't there an equation that talked about x's and y's? Remember that 2x plus y equal to 30? Well, if y has to be greater than 0, and y is the 30 minus 2x, then doesn't that 30 minus 2x then have to be greater than or equal to 0, since that represents what y is, and y has to be greater than or equal to 0? So if you were to solve that equation, you would end up getting x has to be less than or equal to 15. So those are kind of my endpoints, right? Those are my parameters. X could be as low as 0, but as high as 15, because if you went any higher than 15, then my parameters from the original problem wouldn't work, okay? So really now, my endpoints are 0 to 15. I've got my critical numbers, my 15, 5, and now I've got my endpoints, 0 and 15. And in order to find our absolute maximum, we want to take those critical numbers and my endpoints, and remember, plug them into my original. And remember, in this problem, our original problem is the one that we're trying to find the maximum or minimum of. I'm going to use this black circled, clouded equation. So let's take our critical numbers, our 15 and our 5, and our 2 endpoints, which is 0 and happens to be 15 again, and plug them into our original. So I'm going to plug these in to my 900x minus 120x squared plus 4x cubed, because that's the equation I want to find the highest value for. Do that, see if you get the same answers as I do. I ended up getting 0, 2000, and 0. And so if we're trying to maximize this idea, then really we want to make sure that we choose x equals 5, don't we? Because when x equals 5, the product of x times y squared, or this nicer looking equation, ends up being 2,000, which is the maximum possible value. But now the directions ask us not just to find x, doesn't it also ask us to find y? And so what we have to do then is we've got to plug x in, because now that we know x is 5, we've got to plug it in to figure out what y is. So if x is 5, then I can use the equation, remember that secondary equation, and I can plug 5 in, and I could get that y then, when x is 5, that y equals 20. And so if x is 5 and y is 20, then the question says, what do my values have to be to get a maximum product? Well, x has to be 5 and y has to be 20 in order for that x times y squared to be the most possible value. Okay? Lots of different things going on, so you've got to be careful. I'm going to run through it real quick one more time. The first thing I did is I tried to find the equation that I was most interested in maximizing, finding the maximum or minimum of. In this case, I'm trying to find the maximum of this x times y squared. I can't find the derivative though if I have too many variables, so I had to use my secondary equation to find, to solve for one of the variables, either x equals or y equals. I then used it to find my new updated equation with just one variable. I then followed my steps to find the absolute minimum. I found the derivative, I found my critical numbers, I found my endpoints or my domain restrictions, and then I tested them in my original function to see which one's going to give me the absolute maximum or absolute minimum. Okay? All right, try that one. Listen to that again if you need to. Try some of the homework problems.